Hi, my name is Mark Friesen, and this is my first project for Geography 777 Capstone in GIS Development course. So what we're doing here is looking to see if there's evidence of correlation between high nitrate levels in drinking water and the cancer incident rate in Wisconsin. For this, I created a web application using JavaScript and turf.js. I used the Mapbox.gl JavaScript library to render the GeoJSON data as interactive map layers, and the simple statistics JavaScript library to run the statistical analysis. So on the initial map load, you'll see a choropleth map illustrating the cancer incidence per 100,000 by census tract. There's a modal window over here on the right that gives you a little bit of information about the map, and you can see the rate for each census tract by clicking on it if you want to see that. Also over here, you'll see the wells point layer, and you click on each well if you want, and you see the nitrate layers there. And you'll see that over here a legend pops up for the wells layer. I noticed when looking at the data that some of the wells had negative values for the nitrate levels, so I threw out those wells so that they wouldn't skew the rest of the analysis. So what we're going to do with this analysis is to use the wells point layer to create a hex bid grid of interpolated nitrate level values using the inverse distance weighted method. Using turf.js's interpolate module, we pass it a wells, the wells point layer, grid cell size. In this case, it's in kilometers and number of kilometers wide. And then the coefficient, the distance decay coefficient. So you can do that here in these boxes. These boxes here will only let you enter numbers or decimal points. So if you try to enter letters or anything like that, it won't do it. And if you try to put a 0 or something like that in the coefficient, it'll yell at you to fix it. So if you put in the hex size and the coefficient and then run it, and then we wait, and then it gives us back a hex grid layer that shows the interpolated nitrate level for each hex cell, and like the others, you can click on it and it'll get the values. And you also see over here on the right, there's another layer that shows up. This is a hex grid that shows you the predicted cancer levels in each cell based on the nitrate levels and the actual observed cancer level in that cell. Using the simple statistics library, I ran a linear regression analysis on that data and then mapped the residuals on the same grid as the nitrate data. And it categorized them by how many standard deviations the prediction is away from the observed value. And you can see that over here, the legend over here on the right. You'll see that down here in the southeast around Milwaukee and around Madison, you'll see some pretty high levels of overprediction. And then down west of Madison and up in the central part of the state, you'll see some higher levels of overprediction. You can see over here on the right, under the legend, you can see the regression equation and the R squared value right over here. Looking at how the R squared value and how close it remains to 0 through all the iterations you run this analysis through, it seems like nitrate levels aren't necessarily a good predictor, at least on their own, of cancer incidence. Also, we've got a reset button over here. It'll let you just reset back to the beginning, and you can run it again, putting in different numbers if you like. It tends to run a little faster if you have a larger hex bin grid, or you can just run it again without hitting the reset button, and it'll still just clear it out and run it again anyway. Also, if you after you run it, if you look over here on the left, you'll see an export button that will enable you to download the GeoJSON of this grid file, and that file will include, for each cell, that file will include the interpolated cancer and nitrate values, and also the predicted cancer value, and then the residual, the difference between the two. And you hit export, and it saves the file, and we'll also tell you the name of the file, and we'll include in the file name the hex size and coefficient that you used. So it'll help you keep track of that. So that's it. Thank you very much.